Hello dear students, welcome back to our YouTube channel. As you know that we are studying about the integral transform. Now we have completed our first two chapters. First one is beta and gamma function, in which we have seen the definitions of beta and gamma function. Then we have seen some basic properties of beta and gamma function and different phases of beta and gamma function. And the most important, we have learned about the relation between beta and gamma function in previous lecture and in previous chapter. After that, we have started our second chapter, that is Laplace transform, in which we have studied the Laplace transform, which is and we have seen the definition of Laplace transform, and after that we have seen the Laplace transform of some basic functions. After that we have learned about properties and theorems which are based upon Laplace transform. After that we have seen the application of Laplace transform, how to convert the example into Laplace into another form by using Laplace transform. Today we will going to start our next chapter, that is inverse Laplace transform. Inverse Laplace transform. Inverse Laplace transform. Correct. Today we are going to start inverse Laplace transform. As we can see here, inverse, so we are going to find inverse Laplace transform of some function. As we know that the basic use of Laplace transform is to convert differential equation into algebraic form, and after converting differential equation into algebraic form, we know many methods to solve algebraic equation. After getting the result of algebraic equation, we have the result in algebraic form, and we have question or function in differential form. So we convert that algebraic form into differential equation or differential form, and we will conclude the result by using inverse Laplace transform. So we can define, since we know that let f of t be any function f of t be the class A function such, and f of s, capital F of s, be Laplace transform of Laplace transform of f of t, that is Laplace transform of f of t is equal to f of s. Then inverse Laplace transform of f of s will give us f of. It is the definition. If the Laplace transform of f of t is f of s, then f of t is inverse Laplace transform of f of t, and L raised to minus 1 is called inverse Laplace transform of beta, where L inverse is called inverse Laplace transform of beta. one more definition. Let n be a function of p such that, let f t be a function, let nt be a function. One more definition. Let nt be a function, of t such that division from then nt is called null. Nt is called null function. Now, we have seen the definition inverse Laplace transform. Let f of t be a class A function, and f of s be a Laplace transform of f of t, that is the Laplace transform of f of t is equal to f of s. Then L raised to minus 1 is called inverse Laplace transform. Inverse Laplace transform of f of s is equal to f of t, where L inverse is called inverse Laplace transform operator. Correct? And let n of t be a function of t such that integration from 0 to t0 n of t dt is equal to 0 for all t is equal to 0, then n of t is called null function. Correct? Why we are learning inverse Laplace transform is, the main reason is, when we come across a differential equation which is very complicated to solve, we convert that Laplace or differential equation into algebraic equation. Why? Because we know many methods to solve algebraic equation. So, and it is easy to solve. Algebraic equations are more easier to solve than the differential equation. So, we use the Laplace transform to convert differential equation into algebraic form. After converting into algebraic form, we try to solve that algebraic equations, and after solving that algebraic equation, we get result. We apply inverse Laplace transform to convert that solution into solution of differential equation. So that's why we use inverse Laplace transform to convert that answer into algebraic form. Also, we will need a null function, and the definition of null function is, let n of t be a function of t such that integration from 0 to t0 n of t dt is equals to 0. Then we can say that n of t is called null function. Similarly, in next lecture we will see first shifting theorem, second shifting theorem, then linearity property, scaling property, and many theorems which we have learned in Laplace transform. Same we will learn in inverse Laplace transform. So, in next lecture we will try to see some examples or some theorems based on inverse Laplace transform. After getting result for that theorems, we will try to solve example based on that theorems, and we will need some basic in basic inverse Laplace transform of some basic functions. So we will try to solve that basic example also by using inverse Laplace transform in next lecture. So please keep watching our videos and keep practicing each and every example and theorem which we have learned in this lecture. Before going to start our theoretical part, you have to understand and learn each and every step of Laplace transform. So please go through from Laplace transform and try to remember each and every statement of Laplace transform. So by using that statements, we can easily understood and try to solve inverse Laplace transform. So please stay with us and keep watching our videos. Till then, thank you. Bye.